In this video, we are going to learn three things. Number one, we are going to learn how to derive the first equation of motion using the definition of acceleration. Number two, we are going to learn how to derive the second equation of motion using the definition of average velocity. And then the third equation, we are going to learn using the definition of average velocity and the first equation of motion. So stick with me. Alright folks, let's begin with the first equation of motion. This is the foundation, the genesis. Acceleration, by definition, is the time rate of change of velocity. Is the time rate of change of velocity. Triune components, time, velocity, acceleration. Can you see these three things? Acceleration, time, velocity. So mathematically, acceleration means small letter a, right? Equals, then we have velocity, which is a change in velocity. So the whole of change in velocity is delta v divided by time, which is t. This is not magic. This is the practical interpretation of the definition. The a here means acceleration. All right, then delta v means change of velocity. Can you see my arrows? Change of velocity. Then the time, of course, is gotten from time. Can you see that? So this is the interpretation of the definition. Hence, we need to expand delta v. But delta v is v minus u, which indicates final minus initial. So let's substitute into the original formula so that a equals v minus u over t. Can you see this? Our goal is to make v the subject of the formula. Hence we cross multiply. Then we have what? A times t equals v minus u. Is that clear? Hence, if we move minus u to the other side, then we are left with v. So we now have v equals u plus at. This gives us the first equation of motion. Very simple, right? That is it. You can practice this on your own. All right? Then recall that each of these parameters has its own meaning. The v there means final velocity. So let me write it quickly. Where a equals acceleration, and it is measured in meters per second squared. Right? Then v equals final velocity, which is measured in meters per second. Then u equals initial velocity, which is measured in meters per second. And then t equals time, which is also measured in seconds. I hope this is clear. All right, let's derive the second equation of motion. The second equation of motion, which is linear motion, can be derived from the definition of average velocity. Average velocity. By definition, what is average velocity? You can define average velocity as the ratio of total distance, right, covered. The ratio of total distance covered to the total time taken to cover that distance. Right here. So the triune components here, we have distance, we have time, we have average velocity. So mathematically, if we are going to represent this using symbols, then average velocity, okay, means 1 over 2. All right, that is average. Then velocity means v plus u. All right, so that we have v plus u over 2. Can you see the derivation of average velocity? So we're going to use this part. We're going to connect it to this definition in black color. So the ratio there simply means division sign. All right, distance means s, and then time means t. Can you see the combination? This is how you are going to derive this formula without stress. Hence, let's combine the two because the definition combines these two. So left hand side, we have v plus u over 2. That's combining the two now. So v plus u over 2 is for left hand side, then right hand side s over t. So v plus u over 2 equals s over t. It is balanced. The equality sign means they are the same, right? So next step, we're going to cross multiply, right? The main goal here is to make what? S the subject of the formula. Hence, let's proceed. So they'll have 2s equals what? V plus u into t, right? So that we divide both sides by 2. 2 will cancel out 2, then s equals v plus u over 2 in bracket into t, all right? So from here, we also know that from equation 1, okay, from equation 1, we know that v equals u plus at. So meaning we're going to replace v with u plus at. Hence, we say substitute the value of v into s equals v plus u over 2 multiplied by t. All right, so that s equals, open bracket, for v, we'll write u plus at plus u divided by 2 multiplied by t. Next step, u plus u will give us 2u. So we have 2u plus at divided by 2 into t. Can you see that? Let's remove the bracket. So that we say 2u multiplied by t will give us 2ut. Then at multiplied by t will give us at squared divided by 2. All right. So s equals 2ut divided by 2 plus at squared divided by 2. So that 2 will cancel out 2 from here. All right. If we do that, then we'll be left with s equals what? S equals ut plus 1 over 2 at squared. This gives you the second equation of motion. Can you see that? Yes. So let's move to the third equation of motion quickly. For third equation, I'm going to use a simpler method for you. So pay attention to this. For third equation, number 1, we're going to use average velocity formula for equation. And number 2, we're going to use the first equation of motion, the combination, by making t the subject of the formula. Is that clear? So these are the combination that we're going to use in order to derive the third equation of motion. So if you are ready, let's go. We know that average velocity means v plus u over 2, and it's the same thing as s over t. So we'll cross multiply from here so that we have 2s equals v plus u into t. All right. So we divide through by 2. Let's do that quickly. So that s equals, open bracket, v plus u over 2 into t. Well, we're going to make t the subject of the formula from equation 1. So t will now give us what? Let's do it. V equals u plus at. And then if we are making t the subject formula, we'll say what? V minus u, v minus u over a. All right, so we're going to substitute that into what we have before. So s equals v plus u over 2 into v minus u over a. Can you see that? Solving further, s equals v multiplied by v. All right, then we have v multiplied by minus u. So they'll have then positive u multiplied by v. Then we have positive u multiplied by negative u. All right, so they'll have negative u times u. Is that clear? All divided by what? All divided by 2 multiplied by a. So they have 2a. Is that clear? Then we can cancel out some part from here. So that s equals v squared minus vu plus uv minus u squared. over 2a. So minus VU plus UV, they are the same. They cancel out each other. Hence, S equals V squared minus U squared over 2a. All right? The goal is to make V squared the subject of the formula. So let's cross multiply. So they'll have 2as equals V squared minus U squared. So if we move negative U to the other side, then we'll have V squared equals U squared plus 2as. This gives you the third equation of motion, the triune method.